All right, here's the second video from section 4 of practice test 2. Section 4 is the calculator section, and in this video I'm going to go through questions 11 through 20. So in a previous video I did these guys, which are 1 through 10. So I'll pick it up here with 11. So you're given all this information. It says Tony is planning to read a novel. The table above shows information about the novel, shows all sorts of stuff. Oh, here, finally we're getting to the question. Which of the following is closest to the number of days it would take Tony to read the entire novel? So if you look through here, there's a lot of information that you won't be using. The only thing that tells us anything about Tony is here's the number of words he reads per minute, and this is the number of hours that he'll read per day. And so it's asking me which of the following is closest to the number of days it would take him to read the entire novel. So it tells me how many words per minute, which I can figure out how many words per day. And if I knew how many words per day, all I would have to know is how many words are in the novel, which is this last guy down here. So I think these other rows I'll completely ignore. And so let's see, the number of words he reads per minute is he does 250 per minute. And I would like that to be in hours. So I'm going to multiply that by 60. If you take 250 and multiply it by 60, I guess you got a calculator so you can use it. But it'll turn out you'll get that number, I think. Let's use a calculator. 250 times 60. And yeah, you get what, 15,000? And this is words per hour. Nope. Yeah, per hour. So he's reading that many words per hour, but he's reading 3 hours per day. So what that means is 3 times this number, 450,000. Nope, missed a 0 there. 45,000. Maybe I should put commas in up here so it's easier to read. Words per day. So then all you gotta do is figure out how many total words there are in the novel, this number here, and take this number and divide it by this number to figure out how many days you have. So you have 349,000 and a little bit of change, 349,167, and you can divide that by 45,000. And what you end up with is 7.76 days. And so if you go through and read, it says which is the closest to the number of days it would take. Sounds like 8 is the closest, so that would be my answer. All right, number 12. On this date, there were this many tons of trash in this landfill that has this is its capacity. And then the trash increases by this much every time period. So what it's asking for is an inequality. Which of the following inequalities describe the set of years where the landfill is at or above capacity? So I want the amount of trash, which I start out with, maybe this is my trash over on this side. I start out with 175,000, but then I'm getting more. I'm adding 7,500 every year. So this is how much trash I have. I want my landfill to be at or above capacity. So I need the amount of trash here to be greater than or equal to whatever my capacity is. In this case, 325,000. So I stare at my list of possibilities and look for something that looks like this. It looks like I have it right there. So that would be my answer. I guess you go through and prove why the rest of them don't work. And I don't know why in this one it appears they took the 175 and the 325 and subtracted those to get 150. But they didn't do it down in this one. But whatever, D appears to be the right answer, so we'll call that good and move on. 13. A researcher conducted a study to determine whether people in a certain large town prefer to watch sports on TV or go to the game. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors make it least likely that reliable conclusions can be drawn? So what's wrong with this study is essentially what this question is asking. Is it that the sample size is too small? Well, 117 people, that's not great. I mean, you'd always prefer your samples to be larger. 117, I guess that's decent. It doesn't tell me how many people are in the town. I'd kind of like to know that. But 117 isn't so low that it would immediately be problematic. So I would guess that this would not be the correct answer, even though, I don't know, that's kind of questionable there for A. B, no problem with the population size. The number of people who refuse to respond, only 7 of the 117. That's not a whole lot at all, less than 7%. No problem at all. Where the survey was given, yeah, I don't like that. I don't like that all 117 people happen to be out at this specific restaurant on a Saturday. Maybe if you go out to a restaurant on a Saturday, you're the type of person that likes to go out and do stuff, and therefore you're more likely to go to a game than to watch it on TV. Or maybe the specific restaurant is a really expensive restaurant. And the people that go there on a certain Saturday night got a lot of money to throw around, so they're able to go to these games. I don't like asking everybody at this specific restaurant. So I think that both A and D are a little bit problematic, but D is a lot more problematic. So D would be my answer to this question. 14. We got miles traveled and let's see, the number of miles per year, I guess is what's going on here. According to the line of best fit, so look at the line, not at the dots. Which of the following best approximates the year in which the number of miles traveled by air passengers in this country was estimated to be 550 billion? Well, 550 billion is right here, so if I follow that across, I'm talking about this year. Well, that's almost a straight line, somewhere in there. So what year is that? Well, it's greater than 2000 and less than 2010. And you're like, oh, but a couple of these are. Okay. It's also less than 2005, which is halfway between 2000 and 2010. So the only one that's between 2000 and 2005 is 2003 here, which appears to be the answer. 15. The distance traveled by Earth in one orbit around the sun is this ridiculous amount. Earth makes one complete orbit around the sun in a year. Yep. Of the following, which is closest to the average speed of Earth in miles per hour? So really, what I have is it goes 580 million miles per 1 year. But I don't want to know miles per year. I want to know miles per hour. So what I want to do is convert this into hours. For this specific problem, you might be like, well, there's 365 days in a year. And so I'd multiply this by 365. And then there's 24 hours per day, so I'd multiply by 24. And that'll work in this specific case. A more general way to do these conversions is if you have 1 year, when you're doing conversions, you always want to multiply by 1. So what's inside these parentheses has to equal 1. And I want to get rid of year as my unit, so I'll put that down on the bottom. My new unit, maybe I'll find days. In order for this to be equal to 1, I'd have to say 365 days over 1 year, ignoring leap years, I guess. So now what will happen is these units will kind of cancel out and my new answer will be in days. I don't want days, I want hours. So I multiply by 1 again. I say there's 24 hours in 1 day. Note that again, this is equal to 1 because fractions equal 1 when the numerator is the same as the denominator. So now days cancel out and my new unit is hours. And my number is just 1 times this fraction, which is just the 365 times 24, which we had talked about before. I think in this problem is a little bit more obvious that to change into hours, you multiply that and get 8,760. Oops, 8,760 hours. But in different cases, when the units are going in both directions, it can help to write it up this way. So, but wait a minute, I don't see that answer over here. Right, that's how many hours I have. So really what I'm trying to figure out is 580 million miles divided by 8,760 hours gives me how many miles per hour? Well, let's see, 580 million divided by 8,760 hours gives me 66,210 approximately, which is damn near A here, so my answer would be A. 16, results of the bar. So these are the people that passed the bar, these are the people that did not pass, these are the people that took the review course, these are the ones that did not. If one of the surveyed graduates who passed the bar exam is chosen at random, so I'm only looking at these 25 people right here, what is the probability that person did not take the review course? So I'm talking about these people right here. I'm talking about 7 of these people out of the 25 total. My answer would be 7/25, which is B. 17 up here. The atomic weight of an unknown element in atomic mass is approximately 20% less than. This happens a lot, this some percent less than. If it's 20% less than something, it's 80% of that something. Being able to do that immediately and recognize that is really helpful in these tests. Anyways, the atomic weight of calcium is 40. Which of the following best approximates the atomic weight of the unknown thing? Well, the unknown thing is 80% of this 40. So yeah, to be 20% less, you're 80% of that thing. You multiply these two numbers together, you'll get 32, which is answer C. 18. A survey was taken of the value of homes in a country, and it was found that the mean home price was 165,000, but the median was only 125,000. So my mean is bigger than my median. What could cause that to happen? Well, really what ends up causing the mean to be a lot bigger than the median is having outliers, or I guess they don't even have to be outliers, but really large values in my survey. The way to think about it is if you have some average and then you introduce some super expensive house, some $1 million house, that's going to increase the mean a fair amount, but it's not going to increase the median a whole lot. The median is just the middle result, so it'll just be the next one up in my big list of houses, almost the same as the one right before it. But the mean, I have to add up all those values and divide by how many I have. So if I add in another million to my numerator, it'll increase this more. So generally speaking, when your mean is greater than your median, what that means is you have some really large values in there. So let's go through and read this. What could make that happen? The homes have values that are close to each other? Nope. There are a few homes that are valued much less than the rest. Close, but nope. There are a few homes that are valued much more than the rest. There we go. Many of the homes are between these values. Nope. C would end up being the answer. 19 and 20 are based on this table here. We got 300 students over here that go to Lincoln and 300 over here that go to Washington, and we're keeping track of how many siblings they have. There are a total of 2,400 students at Lincoln and 3,300 students at Washington. What is the median number of siblings for all the students surveyed? So the median is the middle one. We have 600 students surveyed. So to find the middle student, you're looking for the 600 plus 1 divided by 2 student. So 601 divided by 2 is roughly 300. I'm looking for roughly the 300th largest student. If I count up from the bottom, I'm looking for the 300th one. Really, it's 300 plus 0.5. So I'm going to take the 300th and the 301st and average their values. But in this case, I think those will end up being the same. So if I were to order these from least to greatest in terms of siblings, where would 300 be? Well, I get 260 students that have 0. So I'm not up to 300 yet. When I got to the 300, I'd be looking at these zeros. So picture 260 zeros right here. And then a whole bunch of ones, 190 more ones. I'm counting down this list and trying to figure out where's 300. Well, right here is 260, so 300 is somewhere in here. 300 is my median. My median will be one of these ones somewhere in here. The answer to this question will be 1. Number 20, based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? It's tempting to say they'd be the same, right? Either way, I have 10 people that have 4 siblings. Either way, 10 of the 300 students surveyed, in other words, 1/30th of students have 4 siblings. So you think it's the same, right? But it's not, because there's more students at Washington than there are at Lincoln, right? So at Lincoln, I got 2,400 students. So if I take that 2,400 and multiply that by 1/30th, I'll get 80, which is the number of students that I expect at Lincoln to have 4 siblings. If I do something similar at Washington, there I have 3,300 students, and I multiply that by the 130, I get 110. So at this school, I expect 110 students to have that many siblings. Here I expect 80. Looks like I expect 30 more at Washington. See if we could find that. The total number of siblings, students with 4 siblings, is expected to be equal. No, tempting, trick question. I bet if you got that wrong, you put that as your answer. The total number of students with 4 siblings at Lincoln is expected to be 30 more than Washington. No, Lincoln's supposed to be less than Washington. Total number of students with 4 siblings at Washington is expected to be 30 more than Lincoln. Yup. The total number of students with 4 siblings at Washington is expected to be 900 more. Not sure how the hell they came up with that. That certainly is not the answer. The answer is C. So I'll stop this video here.